asking to explain why the change in enthalpy for the formation of iodine gas from iodine solid is larger than the delta H for the formation of bromine gas from bromine liquid. So in both of the elements have London dispersion bonding, but iodine is a lower group on the periodic table, so it has more electrons, which makes its delta H formation greater than the delta H formation for bromine. In question B, it's asking to predict which of the two processes shown in the table has a greater change in entropy.
Okay, so for 5C, we're trying to find whether IBR or BR2 has a greater molar enthalpy of vaporization, and IBR would have a greater molar enthalpy of vaporization because IBR is composed of stronger bonds than BR2. IBR is composed of polar covalent bonds, while BR2 is just composed of London dispersion forces. And polar covalent forces are stronger than London dispersion forces. And the stronger the forces are, the higher the molar enthalpy of vaporization. Therefore, IBR has a greater molar enthalpy of vaporization. For 5D, we're trying to find out why the layer of hexane is light purple while the water layer is colorless. And the reason for that is because I2 mostly dissolves in the hexane layer because they're both nonpolar, and if you remember, like dissolves like, so polar substances dissolve in polar solutions and nonpolar substances dissolve in nonpolar solutions. So hexane is nonpolar while H2O is polar, but I2 is nonpolar because it is just composed of London dispersion forces, so it dissolves in the hexane layer, which makes it light purple.
So in letter E, number 1, we're trying to draw the Lewis electron dot structure, and iodine has 7 electrons, and we want to do 3 times 7 plus 1 because it's an ion, so it's an extra electron. So it equals a total of 22 electrons. So you want to fulfill each of the iodine, so 7, 2, 4, 6, and then you want to draw it in this notation with the brackets. And the second one here, it's asking which layer, water or hexane, would the greatest concentration be, or where would the concentration be higher? It would be higher in water because it's polar, it's an extra lone pair, so it's more soluble, so the ion would interact with the polar water molecules, and hexane is nonpolar, so it would not interact with this ion.
This has been AppChem with Michelle, Rena, and Remley.